we are going to look at the simple test of hypothesis. We look at hypothesis testing. Hypothesis testing, how do we start hypothesis testing? How do we determine appropriate test statistics for hypothesis? We'll be able to specify the statistical significance level. We'll determine the decision rule. How do we collect data and perform calculation in hypothesis testing? And lastly, deciding whether to reject the non-hypothesis or to accept the non-hypothesis. We start with hypothesis testing. What is hypothesis testing? Hypothesis testing is a systemic method used to evaluate data, and it aids in decision-making process. So the following are typical steps that are involved in hypothesis testing. The first step is to state the hypothesis in the null form. Some people will like to state both the null and the alternative, but conveniently and in statistical form, it is better once you state the null, the inverse implies. So the first step is to state the null hypothesis. The second step is to determine the appropriate test statistics that will be applied to the hypothesis. The third is to specify the level of statistical significance that you will apply. The fourth is to determine the decision rule for rejection or accepting the null hypothesis. The fifth is the data collection. Perform the needed calculation. What data do you have? How do you calculate it? So the sixth is the decision to reject or to accept the null hypothesis. And the seventh is the process of discussing in detail example or prediction or forecasting using the decision you achieve to make an informed decision. So we look at the second one, starting the hypothesis. So after developing your initial research hypothesis, what is next? It is important to restate the null hypothesis before you carry on. Mathematically, the null hypothesis is stated in a statistically, the null hypothesis is supposed to be stated in a negative way. Hypothesis, first of all, let us not forget. Good morning, students. This morning my name is Dr. Mobosi Andrew. This morning we are going to continue with our ECO122 lecture where we stopped. We are discussing about hypothesis. So we are going to continue from how do we determine the appropriate test statistics when we are about testing hypothesis. So the test statistics, it matters a lot, and the appropriate test statistics to testing hypothesis depends on the characteristics of the sample population in terms of the size of the sample and the distribution of the sample. The test statistics always assume many numerical value. So dictating which best test statistics to apply matters a lot when talking of hypothesis testing, because this informs the type of decisions that we take when we are testing hypothesis. So most test statistics follow some general pattern. For example, appropriate test statistics to use when testing the hypothesis about population mean is the Z test statistics, and this follows normal distribution. So here we have some symbols that represent the parameters we use in test statistics. We have Z, which we said that represent a normal distribution while testing. We have X bar. X bar is denoted with the mean of the sample. So we use X bar to represent the mean of the sample. We use the mu to represent the mean of the population. The sigma to represent the standard deviation. Y sigma square is used to represent the variance. of a test statistics. We have other symbols you could use to represent the number of observation or the population of the study, like N statistics. So in specifying the statistical significance, we pay proper attention to the alpha. We remember that first of all, in stating hypothesis, the null hypothesis matters. And for us to reject the null hypothesis, the decision we take matters a lot. And the test statistics guides the decision in rejecting or accepting the null hypothesis. But there is a key factor why you reject null hypothesis. Rejecting a null hypothesis that ordinarily is true and supposed to be accepted will lead us to committing what we call type 1 error, as we said before. And accepting a wrong null hypothesis leads us to committing type 2 error in test statistics. And committing a type 1 error is a problem, because it means that your outcome and your conclusion is totally biased. But again, in trying to avoid committing test statistics, the size of the alpha matters a lot. So in trying to avoid committing test statistics, we have some challenges. But here the probability of committing type 1 error is represented by alpha, while the probability of committing type 2 error is represented with what? Beta. So here, as the value of alpha increases, the probability of committing type 1 error also increases, because alpha represents type 1 error. So also when the value of beta increases, it means that the probability of committing type 2 error will as well increases. So the probability of committing these two errors is being carefully handled. And in avoiding these errors, we make use of the significance level in statistics. We make use of significant level. So for you to choose the appropriate significant level, you need certain measure in order to choose this. So normally, conventionally, we have 3 significant level we normally dwell on. That is the 0.05 significant level, 0.01 significant level, and 0.001 significant level. Here, 0.05 significant level is a sign that you are 95% confident that the decision you are making, that is the decision in rejecting or accepting your hypothesis, is 95% right, giving only 5% to error. But in using 0.01%, it means that you are 99% confident that the decision you are taking or the decision you took is 99% right, giving only 1% to error. Also using 0.001% symbolizes 99.9% chances of making an informed decision and leaving only 1% to error. So normally in test statistics we use 0.05%, that is 95% confidence interval, as a very good fundamental rule. The reason is because making 99% assurance of your good decision somehow is overestimated or overcarried. So we normally try to give halfway, give little chance for error, because nobody is right. So that is why conventionally we use 5% significant level, that is 95% significant level, so that we leave 5% to alpha, that is type 1 error in test statistics. So here the trade-off for choosing a higher level of uncertainty, that is the significant, is that it will always take a more stronger statistics to have your evidence in order to reject your null or to accept your null hypothesis. Next, we look at determining the rule, decision rule. How do we, check our decision rule? The decision rule here depends on the significant level you are using. It depends on the significant level you are using. If, for instance, and also it depends on the hypothesis you stated. If you state your null hypothesis, decision rule normally is guided by your alternative hypothesis in test statistics. When your alternative hypothesis says that mu, for instance, is not equal to 0. Not equal to 0. It means two-sided hypothesis. Not equal to 0 means it may be greater than 0 or less than 0. In taking your decision, you take the kind of decision, you take the rule that gives opportunity for that two-ended decision. But if your null hypothesis says that the mu, for instance, is greater than 0, you look for upper bound decision the rule to take, and if it says less than, you do the other way. So that is why stating null hypothesis again is key to the decision you are taking. So conventionally, when we are using 5% level of significance, we normally make a rule of thumb that when the t statistics is greater than or equal to 2 in absolute sense, whether negative or positive, we say that the test statistics is significant. And whenever the test statistics is significant, it means we are going to reject the null hypothesis. And rejecting the null hypothesis implies that the alternative follows. So as I've told you before, the null hypothesis is always stated in a negative way. So it's subject to rejection or acceptance. So the decision rule can be stated in terms of computing the null hypothesis in probability terms, so as to know if we are rejecting or we are accepting. So, but here, the same decision will be reached regardless of which method is chosen. So, one key area again for you to see if the null hypothesis, the test statistics, or the decision you are taking in hypothesis testing is good is the structure of the data. So it means that collecting data and performing calculation matters a lot. The type of test statistics we choose, the type of data we collected, the type of decision rule, the type of hypothesis we stated, the alternative hypothesis matters a lot. So the method of collecting data determines the early research process in testing hypothesis. It informs the type of hypothesis, the nature, and once the research question is determined, one must take decision regarding what type of data is needed and how the data will be calculated. So the decision establishes the basis for the data to be analyzed. So this should use an appropriate method and data collection analysis. So all these things guide us to make our decision when we are testing hypothesis. So deciding whether to reject the null hypothesis is a matter of the result of your test statistics. Your test statistics, like we said, when your alpha is increasing, it means that your chances of committing type 1 error increases. So but a higher alpha determines the decision you take. So if you reject, as we said, if you reject a true hypothesis when it's supposed to be accepted, it means you are committing type 1 error. And accepting a false null hypothesis when you ought to have accepted it, you commit what? Type 2 error. So here we'll be able to discuss hypothesis. How do you state your hypothesis? We said that we state hypothesis in null hypothesis and the alternative implies. In some circumstances, in fact, conventionally in statistics, immediately you state your null hypothesis, you don't bother about the alternative hypothesis. But in so many departments that are not statistically based, they state both null and alternative hypothesis.